Hello, learners. Here we are once again doing the mathematics which I've already studied a long time ago. But in this video, we are to be introduced into another concept that's about variation. Having had enough about the Cartesian plane, where we're doing the coordinate geometry, let us now shift our mind to something else. Right, here we are, not wasting time. Let us get to know about the objective that will help us to move along until we finish the entire topic. As students, make sure at the end you should at least be able to do the following 4 objectives. These are the main ones. Be in the position to solve problems involving direct variation, then solve problems involving inverse variation, solve problems involving joint variation, and lastly, should be in the position to solve problems that involve partial variation. Right, so only 4 are the main ones, but there are a lot of issues that we're going to learn behind these main objectives. Right, now let's define what it is about this topic. When we talk of variation, in our case, what does it mean? By the terminology itself, variation can be defined in different ways, but here mathematically, what is it that we are trying to emphasize? Right, in this topic, we are going to focus much on the quantities. Right, we will be focusing much on the quantities. What about it? Here, we are there simply going to look at the relationship amongst the variables, which are also defined as what? Quantities themselves. Right, so we are there just looking at the relationship that exists amongst the quantities or amongst the variables as such. Like say, how do you compare the change in X versus the change in quantity Y? Or how do you compare the change in the variable X and the variable Y? Say if something is happening to X, that has also an effect to the another variable Y. So we'll be looking at that relationship that exists. Right, amongst the quantities, it can be between or several other quantities. Right, so as such, if we were to define the variation, you can just define it that says just a topic that looks at the relationship that exists amongst what? The variables. Right, relationship among the variables. Right, and the relationship that is there, we are to discuss, will be there based on the particular constant. Right, so if I'm talking of the change in X, variable X, to say as X changes, that has got an effect on the other variable Y, the change is there based on a particular what? Constant. That's the thing. So we need at least to focus on this quantity that we'll be discussing upon versus the particular constant. Say talk of the constant, what is it that we're talking about? What about the quantity X, like say X and Y? What are these quantities? Because here we talk of X and Y are just like representation of particular what? Exact what? Quantity. That's why we call them as the variables. Right, so now before I talk much about these quantities, let me first of all inform you that the relationship that we are going to focus here will be just based on only 4 ways. Right, so which we are to say that the quantities can vary in 4 ways. Of course, there are so many ways how the quantities can vary with one another. Like the variation here, let me emphasize on here to say when we talk of the variation, we'll be specifically looking at the changing. As one quantity is changing, what exactly happens to the other quantity? That's the thing. Right, so if one varies, the other one also changes, something like that. Talk of the variation amongst the quantities as such. So the system that happens, how quantities vary, is done in 4 main ways. And this matches up the objectives here. Right, so the quantities can vary, one, directly, right? The quantities can also vary inversely. The quantities can again vary jointly. And then the quantities can also vary partially. Right. As such, our discussion will be based on these four main ways of variation. Then now, what is it that we have now in the topic? Then we are there to discuss the direct variation, inverse variation, joint variation, partial variation. We look at the system as quantities are changing partially, jointly, inversely, and what? Directly. That's it is about this topic. Right, so to make things healthy and well understood in the discussion, we'll be looking at these variations one at a time. Right, say what is it that we should know about the direct, how quantities vary directly, what is it about the inversely, to say how does quantities vary inversely, then jointly, and at the very end, we have to look at each about the partial variation. So if you look at what we have here and the objectives that we have here, they're exactly in line. Talk of in your case, at the end, there will be problems that you need to solve. So you have to solve problems involving the direct variation, talk of problems inverse variation, and problem about joint variation, and finally, the partial variation. So now, without wasting time, let us get into the first discussion about the variation, and this is direct variation. Let's see how does quantities vary directly, or how does variables vary directly. Right, so for you to be in line and be able to understand better, I'm going to give you a realistic example that involves the real life situation for you to understand it. When you talk of quantities vary directly, what could be good example that you too can also use to come up with your own examples and be able to detect or deduce that really quantities here are varying directly. Right. Remember, this is not only mathematics. The knowledge can also be applied in other areas of concern, talk of physics, chemistry, and sometimes in biology. Right. One, that's the direct variation. Variation. Right. To make it simple, when we say quantity vary directly, we are looking at the quantities. Say, for example, one quantity X versus quantity Y. What happens to the change in X affects the change, affects the other quantity, like quantity Y. So how this one changes and how it affects the Y, that determines the direct variation. So when we say things are really directly varying with each other, quantities are varying directly with each other, how do they vary directly? Right, that is the point that we need first of all to focus before we go into the what? Examples and exercises. Right, when we say X varies directly as Y, we are looking at a situation whereby the same measure that happens to X, right, that will also affect the what? The Y. Like what? It will be like when, for example, a variable X, a quantity X increases, it changes by increasing. The quantity Y will also what? Change. By what? Increasing. More like by the same measure. So it's like when X increases, we should expect Y also to increase. Right. So when X is affected, Y is also what? Affected. It means the two quantities are what? Related. So it's like this one is changing, that one is changing. We say the two quantities are varying with each other. Right. And vice versa, if it happens that maybe quantity X decreases, we also how it also happens that quantity Y will also what? Decrease. Right, such type of scenario, we say the two quantities are directly related with each other, or X is directly proportional to what? To Y. Right, so we talk of a situation there, X increases, Y also increases. If X decreases, that will also affect the Y. Y will also what? Decrease. Right, so that scenario is what is defined as the direct variation. Right. Now, let me have a good example in the real life situation. What is a good example that we're going to deduce that quantity X increases, quantity Y also increases, or quantity X decreases, quantity Y also decreases. Right. A good example that I can give you is the several. Like if I give you one, if not maybe two, you'll be able to have your own. Let us consider the quantities that is there based on the number of chairs, which are sometimes to be fitted in a particular room. Number of chairs to be fitted in a particular room. Like, so like you'd like to fit the room with chairs. And you know what is there, just like you can fit several chairs in the room. Okay, you can even start this, maybe remove the chairs in the room. So if you're fitting chairs in the room, it means you talk of the issue about increase of the chairs in a particular room. But if you remove some chairs in the room, it means you'll be decreasing the number of chairs in the room. So you talk of, you can increase the quantity or decrease the quantity of chairs. You fit in, you increase the quantity. You remove in, you remove out, it means you are decreasing. So here we'll be looking at a situation whereby as much as we are fitting the chairs in the room, we'll be looking at the number of legs versus the number of chairs. So the quantities here to be discussed will be based on that. So here I've got the issue about chairs. Here our target is to look at the number of chairs. Number of chairs. Let that one be represented by a particular variable. Let me just write maybe C, right? And also then this one should be versus with the number of legs. We know each chair has got legs. So let us consider those chairs which have got 4 legs. Right. So in this case, our focus will be on the number of chairs versus number of legs. Right. So try to think about it. If you have one chair, that one chair has 4 legs. We know that. A chair has got 4 legs. So now what will happen here in a particular room? We have got several chairs outside. It'd be like if I'll take one chair and fit in a particular room, definitely you're going to tell me that the number of legs will be affected in that room. From the start, we don't have chairs in the room. It means we have got 0 number of chairs in the room. It means there'll be 0 number of what? Legs. But now if that room is fitted up with one chair, definitely it means the number of legs will no longer be 0. And definitely you tell me there'll be 4. What if we increase the number of chairs in that room from 1 to 2? Should we expect that the number of legs will also be 4? I don't think so. We have got 2 chairs. So definitely it means the number of legs there would be double. Instead of having 4, now we have what? 8. What if I increase the number of chairs from 2 to 3? Definitely, it means the number of legs here will be how many? Will be what? Will be 12. And if I keep on doing that, at the end I found that if I have got maybe talk over what? That's the 4 chairs, then definitely this will give me what? 16 number of legs. So look at what is happening here. A quantity C or a variable C is changing by increasing from 1 to 2 to 3 to 4. That affects the variable error. The variable error, which represents the number of legs, also is changing by increasing. So this quantity C is increasing, quantity error is also increasing. If I reduce the number of legs in that, I reduce the number of chairs in that room, taking the chairs one by one out, definitely we'll also see that the error will also be what? Affected. So what we have here is just a description whereby we're looking at the relationship that exists between C and error, and we can describe this relationship very well. How to describe it? You'd say as C is changing by increasing, L is also what? Changing by increasing. So just like as C is increasing, L is increasing. If C is decreasing, it means L is also what? Decreasing. So here we say the two quantities are varying directly. C is directly proportional to L. That's what we say. Right, now, having known that, let us now have a detailed study about what is happening C and L. Right, that's now mathematically. You'll be looking at now an issue on how does the L affected. How is L being affected in this case, much that C is increasing? So what is happening here? We are interested just to find out, say, how do we get the values of L as C is increasing? Right, so that at the end, we should be able to describe at least an equation, a statement that is bridging the two quantities C and L in the relationship. There must be that. You know what? Every quantities, whenever we talk of the quantities are varying with each other, we should be in the position to describe that relation by a particular equation. Right, so how does the C and L change? We need to bring the equation down. Say this is the equation of the proportionality. An equation that bridges up the what? The changes that exist between C and L. So that is now we're going to fire for that. So let us look at the way numbers are changing in this case, and we pick up that equation that is bridging C and L. So how to do that? It'd be like when I have 1, it means this one corresponds to 4. So if you look at this 4, how does this 4 come about? You'll be able to tell me that 4 is coming about when we multiply a value 4, which is the number of legs of one chair, by the number of chairs. So it'd be like here, you have got 1 multiplied by 4, it gives you a 4. The sum, if I look at the 8, the coming of 8, 8 will always consider a 2 first. Number of chairs increasing from 1 to 2. So just like the number of chairs, which is a 2, are multiplying by a value 4, which gives us what? 8. Right? Then talk of the 12. If here we have C as 3, then the L is 12. So look at how is 12 coming? 12 is coming from the product of the number of chairs by the number of legs of a single chair. So it'd be like 3 times 4, which is 12. And then finally, 12 of 16 will be considering a 4 to be multiplied by a 4, and this gives us what? 16. So if you look at this situation here that is happening on the board here, you'd find that whatever is here about the effect of the number of chairs from 1, 2, 3 to 4, and also what is happening here to the increase of the number of legs from 4, 8, 12, 16. This change here is more like happening similarly. In the stage 1 where is 1 and you get a 4, the same situation is happening when you have got a 2 and you get 8. The same situation is happening when you have got a 3 and here we have 12. And the same situation happens when you have got a 4 and here there's 16. What is there? Just like you are saying, number of chairs times the number of legs of a chair, number of chairs times number of legs for a chair, number of legs, so the number of chairs times the number of legs of a single chair. And again, here you also talk of the same statement, number of chairs times the number of legs for a chair. So like, now, in this situation, you'll be in the position that you depict that, say, what is happening is just like we have got particular equation that is determining C and L, right? And this equation is found in this location. 4 times 1 give us a 4, 2 times 4 give us 8, 3 times 4 give us what? 12, and also 4 times 3 give us what? 16. So if we are to come up with an equation that can bridge this L and C, in this case, we'll be in the position as to consider to say, if I look at this first column of numbers, talk of 1, 2, 3, and 4, I'll find that these values here are represented by variable C. So whatever I have here, talk of the 1 is a C, 2 is a C, 3 is a C, 4 is a C. It means what I'm doing here, I'm multiplying a C by number of legs for a single chair. So if I'm there to represent the number of legs for a single chair, which in this case, I'll be able to see that this is not changing. What changes here is the number of eggs. So it's always a 4 times this, 4 times that, 4 times that, 4 times that. It means that one is just like a value that is constant. Right, and without it, I don't think the quantity error will be in existence. So it's just like 4 is controlling the whole process there that is happening between C and error. So let us now represent this one by a variable K. So what we have is just like what I'm doing here is just like I'm multiplying a C by a K, where K is my constant. And at the end, what do I get? I get the number of eggs. So this number of eggs is represented by error. So if we are now to have a general representation of all the equations that can be produced in the relationship between C and error, that equation will be in this form. As much as you're able to define what the meaning of the C, what the meaning of error, what the meaning of K. So for us to have a value of error and the value of C, this is the equation that determines the two quantities. And this is known as the equation of proportionality. So as such, it means when we talk of issues about direct variation, the equation of which should be presented in this form. It's just a linear type of equation like C, but multiplied by K is equal to error. Right. So always when you have problems that we will be solving about the direct variation, you'll be able to see that what we'll be doing will be producing an equation of this kind. This is a good example of proportionality equation in the what? Direct variation. Right. So what do we say in this case? So in this case, we'll say if we're going to capitalize that equation, where we've got C times K, give us CK, we'll have error to say in the equation, talk of error is equal to C times K. I'm just written in different form to say when number of chairs multiplied by constant 4, which is K, it gives us error. We say that this is what we say, error varies directly as what? C. To say that if error is increasing, it means C is also increasing. When error is decreasing, it means C is also what? Decreasing. The equation of proportionality should look something like that. That is connecting the two quantities. So you say error varies directly as what? C. Where your K that is existing in this equation is a what? Constant. Right. So at the substatements, when you talk of issue about the changes, the amongness of between quantities, this has to be described that way. Right. Or you may say error is directly proportional to C. It means the changes have the nature of the change taking place to one quantity is similar that happens to the other. And O is determined by a particular constant. That is a K. Right. So as mathematicians, we don't usually write a full statement like this one, but we write in symbols. Like say when you say 5 plus 5, don't write is equal to 10, but you have got a symbol that's just a dash. The same in variation, we need at least to use some symbols. So when you say error varies directly as C, and where K is the constant, the presentation of this statement is written like it. So here I'll write it for you to say briefly. Written as right. So we write error, and this is the symbol, and write it as what? We talk of a C, or C varies directly as error. So if I want to get error, this is the relationship. So when we write error, this symbol C, it simply means error varies directly as C, as much as the equation here is just a linear without a fraction. Right. But now, if I need to work out the value of a C or error when one of them changes, is where now I'll have to focus on the what? The equation. So it means when error varies directly as C, if I want to find C or I want to find the error, it means I have to produce that equation to say, I'll write that one to say error is equal to C multiplied by K, or K times C. So this one will be the equation that I'll be using throughout to solve the value of error if K, if what? If C changes. But rather, the statement, first of all, ends here. So as a student, try to be able to connect your brain and try to understand issue about the direct variation. That say direct variation is talking about the quantities which vary proportionally, in the sense that when one changes maybe by increasing, the other also changes by increasing. Another one decreases, the other one also decreases. And the representation, the light up, mathematically, this is the way we write, like error varies direct as C. But if I need to work out one quantity or the other, it means I should have an equation where I can solve. It means I know the quantity of error, I can find this C by the knowledge of what it is about the K. So I just multiply this by this, then the C, the error is known, then I'll just divide both sides by what I have, either maybe a K, then C is going to be what? To be found. Right, so at the moment, let us just stop here and try just to master the relationship in the direct variation about the quantities and how we represent our light up. Right, so focus on this, I repeat, and also this. We describe the relationship. This is a proportionality equation you can use to work out in one of those two quantities. Right, at the moment, let's stop here and we meet in the next video where we're going to solve some problems. Right, thank you very much.